The number of defects have reduced by about a factor of 1 billion over this period of 100 years. So clearly this is something that material science is all about. Material science is about taking a material that we know that's useful and finding ways in which we can improve it to a point where it becomes beautiful and we can make useful things from it. Let me give you a related example. Silicon, one might say, is a material that came to us from nature. You can find, although it's not very common, you can find pieces of silicon in the earth. And so this is something that was known to humankind perhaps, I don't know exactly when, at least in the 19th century. One could think of making new materials that don't exist in nature, that have a certain property that one might desire. So let me give you a very related example. If you look at a semiconductor, like silicon, in that piece of silicon there are electrons, and something very special to semiconductors, which I'll come back to a little bit later, is the fact that these semiconductors have what's called an energy gap. And this is a consequence of quantum mechanics. The electrons in a semiconductor can exist at certain energies, but they cannot exist at certain other energies, and this region of forbidden energy is called an energy gap in a semiconductor. Now, if you shine light on a semiconductor, you can take a particle of light, what we call a photon, and you can take one of these electrons and you can increase its energy by the amount of energy that the light particle had. In other words, you can take an electron from here and you can put an electron up there. Now, of course, in order to take an electron from here and put it up here, the light particle that comes in had better have enough energy in order to send an electron from this side to that side. So in other words, semiconductors are very sensitive to the energy of the light, and from quantum mechanics that means that they're sensitive to the wavelength of light. So if you look, for example, at a piece of silicon, it looks black, which tells you that it absorbs visible light. Visible light has a certain energy, 1.5 electron volts is what we would call it. But if you look at light which has lesser energy, for example, infrared light, then silicon is transparent to that infrared light, because the infrared light does not have enough energy in order to kick an electron from here up to there. So if you look with an infrared camera at silicon, that silicon is transparent. Now imagine that you want to build night vision goggles. Then silicon is clearly not going to do the trick. You have to find the right semiconductor which has the right energy gap in order to absorb the light that corresponds to infrared light. And back in the 1950s, people, material scientists, theorists, they looked at all possible semiconductors and they came across a beautiful material system which is called mercury cadmium telluride, HgCdTe. And from their theoretical calculations, they predicted that the gap of this material, by changing the composition of the cadmium along this plot, so this is mercury 1 minus X, cadmium X, tellurium, you can tune the gap of this semiconductor continuously all the way from almost the visible part of light to the deep infrared, which means by choosing the right material, by making that right material, which was not something you could find in nature, you could find a semiconductor that was sensitive to the right kind of light. So people first started making mercury cadmium telluride in the late 1950s, and when they started making this material, it was just terrible. This material would absorb anything and everything because the quality of this material was just terrible. And I believe it was the Defense Department which basically funded this work continuously for about 40 years before this material could become pure enough to actually be used. So So this is something fairly recent. I just found it while hunting for mercury cadmium telluride. This is mercury cadmium telluride that's outfitted on most of military planes which have night vision. So this is a picture of night vision rescue that's happening somewhere in the Mediterranean, I believe. And this is really enabled because first there was a prediction of a new material, then there was a sustained effort to make this material and improve this material to a point where we can actually use it for these kinds of things. So that is another goal of material science, to engineer desirable properties in new materials. Now, in reality, material science doesn't work this way many times. So let me give you a very famous example. For those of you who haven't heard it, this is a wonderful example.